Imagine placing a bowling ball on a trampoline. The fabric dips under the weight, right? Now roll a marble nearby. It spirals toward the ball. That's how gravity works in general relativity. Massive objects like stars and planets bend the fabric of space-time, and smaller objects follow those curves. Gravity isn't a force pulling things. It's the shape of space itself. This analogy helps us visualize how mass tells space how to curve, and space tells objects how to move. Now think of time as part of that trampoline fabric. When space curves, time does too. Near massive objects, mouse. Time actually slows down. Astronauts on the International Space Station age just a tiny bit slower than us on Earth. It's not science fiction. It's been measured. This time, dilation is why GPS satellites need to adjust their clocks. Without accounting for general relativity, your phone's location would be off by miles. Gravity literally stretches and squeezes time itself. Picture a race car speeding around a curved track. The faster it goes, the more it hugs the curve. In relativity, objects moving through space-time follow the straightest possible path, called a geodesic, even if that path looks curved to us. Earth orbits the sun not because it's being pulled, but because it's following a curved path in warped space-time. Just like the race car, it's not being forced. It's simply moving naturally along the shape of space. Let's go deeper. Imagine a stretched rubber sheet with a heavy object in the center. Now flick a smaller object across it. It curves around the dip. That's how light behaves near massive objects. Gravity bends light, not because it pulls on it, but because it warps the space light travels through. This was proven during a solar eclipse in 1919, when starlight bent around the sun. Light follows the curves of space, just like marbles on a trampoline. Finally, think of space-time as a giant invisible jelly. Drop something heavy in, it wobbles and sends ripples. These are gravitational waves, and they're real. Detected in 2015, they're caused by massive events like black holes colliding. These ripples stretch and squeeze space itself as they pass. It's like hearing the universe's deepest bass notes. General relativity predicted them a century ago, and now we can actually listen to space-time vibrate. Einstein wasn't just right, he was way ahead of his time.